In today's video, I'm going to be diagnosing a very common car problem, and it doesn't actually involve any dinosaurs. So this car came to me with a really bad rough idling issue. The owner said when it was in drive at a stoplight or a stop sign, the whole car would hum and vibrate, kind of shaking. But when he would put it in neutral or park, the vibration would mostly go away. So this is a really common issue, and not only did I figure out what it was, I fixed it as well. So make sure you stick around. Speaking of vibrations, if you're into good vibes, you're definitely going to want to subscribe to Budget Mechanic. We've got a lot of good stuff coming. Now we've already made an exhaustive video on all the reasons that a car vibrates at idle, and I hope you go check that out. But today, I'm going to be doing a practical application where I'm going to go step by step how I diagnose why this car is vibrating so much when you're sitting at a stoplight. And we're going to start with the easiest things first, because I'm smart. And also lazy. So the first thing I want to do is plug in my car scanner and check out any clues that I can find in the computer. Now this car doesn't have a check engine light on the dash, but if it did, that would be even more reason to plug in the scanner and find out what's going on. Now I am using this scanner by Think Car. They sent me one of these, and I've been using it a lot lately and really liking it. It's really full-featured, and it is pretty cool that you can plug it in wirelessly and walk around. You don't have to get a fancy one. They make some real basic ones that have all the live data functionality for as little as $20 to $30. And we'll put a couple links in the description you can check out. Now the first thing, and the main thing I like to check with the scanner, is the fuel trims. Now this is basically the car compensating for vacuum leaks. Vacuum leaks are a really common reason for a vibrating engine, especially on a little four-cylinder like this. Okay, so here I see the long-term fuel trim is at 7%, which is good. It's in between sort of the nominal values of -10 and +10. So that means it's within acceptable range. If I had a number like 15 or -20 outside of that range, it would mean that the computer is really compensating for some problem in the engine like a massive vacuum leak. And that's where you'd start to see check engine lights on your dash. Alright, so the next little test I'm going to do when it comes to fuel trims is I'm going to get in here, in park, and I'm going to rev the engine up to 2,500 revolutions per minute, and I'm going to just see what happens to these levels. Okay, so it's up at 2,500 revolutions per minute, and I can see that this long-term fuel trim really isn't changing all that much, which leads me to kind of believe that there's not a big vacuum leak. If there was a big vacuum leak, revving this up or mimicking driving down the road would cause this fuel trim to drop significantly, and I'm not seeing a huge drop. Alright, another thing I'm going to check in my scanner is the engine coolant temperature. And the reason I check this is because if something's going wrong with the coolant sensor and the car is not sure what temperature the engine's running at, it can sometimes suddenly run rich or lean because it doesn't know if it's just starting up or if it's fully warmed up, and it can cause the car to run rough. So I'm just going to look at the graph of the engine coolant temperature and see if there's any sudden fluctuations or if it goes to zero. Just a note, when you're doing these scanner tests, it is good to do it after the car is warmed up so that you don't run into warm-up cycles or anything out of the ordinary. So I can see here that I'm at 200 degrees and it's holding rock steady, so I don't think there's any confusion for the computer there. Now while I'm here, I will say that what's cool about this scanner and a lot of scanners that I've used is it shows the battery voltage right up here in the corner at all times. So I can see that it's running at 13.5 volts. So that's a real easy check you can do, because if the alternator was dying, putting out too little voltage, that could cause your engine to run weird as well and cause some shaking. The next thing I'm going to look for is misfires. Now normally if you have misfires, you're going to have a flashing check engine light on your dash and everything will be running really bad. But sometimes if you just have a few misfires every once in a while, the computer won't actually throw a code. But with my scanner, I can go back and I can look at the history if there's been any small misfire events. So that eliminates misfires as a cause for rough idle. The next thing I want to check with the scanner is the outputs coming from my oxygen sensors. Because if an oxygen sensor is failing, it will confuse the computer into putting too much air or fuel into the mix, and it can make your engine run rough. So I'm going to use my live data again, and I'm going to go in here and select Bank 1 Sensor 2 and the Bank 1 Sensor 1 oxygen sensor. One cool thing I forgot to mention before about this specific scanner is that once you select a value that you want to monitor, it will show you the acceptable range that your car is supposed to be at. So I can see here that my Bank 1 Sensor 1 is within the normal range, 0 to 5, it's at 3. And the other sensor is also in the normal range at 0.7 between 0.1 and 0.9. So oxygen sensors are looking good, and I don't think that's the reason for rough idle. The next thing I want to check is engine mounts. Now the engine mounts are what actually hold the engine and the transmission in the car. And they're meant to act as kind of a shock absorber to isolate the vibration from the engine to the rest of the car. Now when the engine mounts break down and stop working, the vibration from the engine goes straight into the rest of the car and you can get that nasty vibration. So most cars have 3 or 4 engine mounts under the hood. What you're looking for is that big rubber section having any cracks or missing chunks, or if it's super stretched one way or the other, that can be bad. They all look pretty good physically from the outside, but one more test that you can do that would really reveal if there's any stress or failing rubber would be to have an assistant get in the car and put it in drive with the brake on. And at that moment that it goes into drive, you can see how much the engine shifts. If it kind of drastically moves when it goes into drive, those engine mounts have a little bit too much free play and they're letting the engine move too much. This engine barely moves at all when it goes into drive. So the engine mounts are working great. Now while I'm here, I'm going to check the air filter and just make sure it's in good shape. A super dirty air filter could cause the engine to run rough. It would have to be really dirty but very easy to check. It's really not that bad. Alright, the next thing I'm going to address is the mass airflow sensor. Now this is a sensor usually found on the airbox or in this main intake, and it basically helps the computer determine how much air is going into the engine so it can make its ratio calculations. But what can happen is this can get dirty or go bad and then the computer freaks out. It doesn't know how much air and fuel to throw into the engine and it can make the engine run poorly. So it's a very easy thing. You want to first disconnect the electrical plug and then it's usually held on by a couple screws or something. When it comes time to pull the MAF out, you want to be gentle because it's a very fragile element. So even if the mass airflow doesn't look dirty, it's a good idea to clean it. Also, sometimes they can fail internally, and one way you can test that is by running the car with it unplugged and seeing if everything runs exactly the same. That means the mass airflow sensor was actually probably not even active in the first place. When you're cleaning the mass airflow sensor, you want to use a dedicated cleaner. If you use brake fluid or something, it could actually damage the sensor and the small parts. Once it's all dried off, put it back in place and get it reattached. After running for a little while, I can say there's no change. Still shaking. The next thing that I want to address is the idle control. On older cars, there was a thing called an idle air control valve that actually controlled the speed of the car's engine at idle. On newer ones, that function is built into the throttle body, which means the computer is setting, under different conditions, how fast the engine runs at idle. What can happen with this throttle body is that if it gets really gunky and dirty, it can get jammed open or jammed closed, and that will totally throw off the idle speed, which could be a huge reason that the engine and the car would shake at idle. So I'm going to remove the throttle body and clean it carefully. You don't want to push hard on the butterfly valve because you can mess it up. Just clean both sides gently and remove any deposits around the pivot point. After reinstalling it and starting the car, it did start a little quicker. But when it's at idle and the air conditioning kicks in, it's just as rough as before. So that did not fix it. The next thing I'm going to do is fairly cheap and easy, and that is replace the spark plugs. When spark plugs get old, their gaps get bigger, they become less efficient, and they can make the engine run a little rougher than normal, but not enough to trigger a check engine light. These spark plugs look decent. Not super black or super white. Maybe a little worn. Since I've already gone to the work of pulling them, I'm going to put new ones in anyway. Well, it still feels like a massage chair. On to the next thing. The next thing I'm going to do is replace the transmission fluid. A really common reason for rough idle, especially when you're in drive, is dirty transmission fluid. After draining it, it looks very dirty, which makes me hopeful. I run it, cycle through the gears, let it circulate, and do another round of fluid change. Still pretty dirty. While waiting, I check for vacuum leaks using carb cleaner, spraying around hoses and intake areas. If there's a leak, the idle would change. I avoid hot exhaust components. I don't hear any change. I tried a lot more after that. New coils. Fuel additive. Checked fuel pressure. Even did a throttle relearn procedure. Nothing worked. Finally, I decided to recheck the engine mounts more carefully, especially the transmission mount, which is harder to see. This time I removed the battery and airbox to get a better look. Sure enough, There were cracks in the transmission mount. It was obvious once I had full visibility. This transmission mount on automatic cars is a very common culprit for engine vibrations. So I replaced the transmission mount. After that, the nasty vibration was completely gone. The car now runs smooth and steady at idle, even in drive. So learn from my mistake. Inspect those mounts thoroughly at the beginning. It can save you a lot of time. If you like this video, make sure to check out our other one about whether you should drive when your check engine light comes on.